In this video, I'm going to do a couple of examples of what's called method of differences, or is occasionally known as telescoping. So you will notice in some questions you get, you will have to make the first step for yourself, but I'm going to focus on we're given a result and we need to work with it. It's only once you've done partial fractions as part of the A-Level Year 13 course that you'll be able to see how to make these splits. So in this first example, I've given you this fact that when you do these fractions 1 over 3r subtract 1, subtract 1 over 3r plus 2, and write as a single fraction, you get 3 over that combined denominator, 3r minus 1, 3r plus 2. And I'm asking you to use this result to find the sum from r equals 1 to n of 1 over 3r minus 1, 3r plus 2. Now, two things we want to notice right at this stage. Firstly, is there's something in common between this thing we've got and this thing we've been told. And there's still something also different. So the denominator is the same, encouraging, we're going to be able to make use of it. But we've got a 1 on the top rather than a 3 on top, and we can't just forget about that. We need to make sure we're careful and pay attention to that rather than just ignore it. Otherwise, we'll get an answer that ends up being 3 times too big. So the first step we're going to make here is we're just going to say, well, this thing we've been asked to find is the same as, well, given this a third of what we were given above, it must also be 1/3 of the sum from r equals 1 to n of 1 over 3r minus 1 subtract 1 over 3r plus 2. So rewriting it using the results we've been given. There must be a reason we've been given that, so let's rewrite it in that form. At this stage, there's not a whole lot of clever work to do now. We just need to do a lot of substituting in and hope we see stuff starting to simplify. So my advice on these is always, we're always going to look at what happens when we sub in r equals 1, r equals 2, r equals 3, and then sub in the final 3 terms as well. On a mark scheme, you can probably get away some of the time with doing the first 2 lots and the last 2 lots, but sometimes you'll miss the simplifying that's happened, and it will certainly make clear there's a pattern there if you go for the first 3 and the last 3. So that's definitely my recommendation. Okay, so what happens when we sub in r equals 1 here? So 1 over 3r minus 1 is going to be 1 over 3 times 1 subtract 1, so 1 over 2. Subtract 1 over 3 times 1 plus 2, it's going to be 1 over 5. So that's what, you don't need to write this, I'm writing on the right hand side here, but that's what happens when we sub in r equals 1. When we sub in r equals, so we're then going to add what happens when we sub in r equals 2. If we do that, we should find we get 1/5 subtract 1/8. So like I say, you don't need to write down this r equals 1, r equals 2 on the right hand side. That's just to help explain what's going on. And then the next one, if we sub in r equals 3, we're going to get 1 over 8 subtract 1 over 11. Hopefully you're already starting to spot a pattern. Now we're going to get some stuff cancelling. I'm then just going to put plus dot 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 to show we've got some more terms happening. We don't know how many though. It's impossible for us to list them all because we're going up to n. So let's focus on what we're going to get when we sub in the last 3 terms. So when we sub in r as n subtract 2, that's going to be our final one. So that was r equals 3. Sorry, I say final one. We've got 3 more terms together. So if we sub in r equals n subtract 2, then we're going to get 3 n subtract 6 and then subtract 1 again. So that's going to be 1 over 3n minus 7. And when we sub in n subtract 2 into your next fraction, you're going to get 3 times n minus 2. So 3n minus 6 again, but then plus 2. So that's going to be 1 over 3n minus 4. And then we're going to do the same, subbing in r equals n minus 1. Well, that's going to give you 1 over 3n minus 4, subtract 1 over 3n minus 1. And finally, subbing in r equals n, that's hopefully a nice easy one for us to do. We're going to get 1 over 3n minus 1, subtract 1 over 3n plus 2. Now, at this stage, we want to make clear what simplifications are happening. So we should hopefully notice this subtract a fifth and add a fifth is disappearing. So you just need to make it clear how they're pairing up. This little bubble layout that I do, I think, is the clearest way of showing that. It's not the only way you could use, but that's my preferred method of showing what's happening. So those 8s are cancelling, and then if this pattern's going to continue, if we look down here, those over 3n minus 4s are going to disappear, and over 3n minus 1s are going to disappear. And the ones in the middle, which I haven't circled, they are going to have something to cancel with. We just haven't shown them all. What we're going to be left with here is just going to be 1/3. Remember, don't lose our third to that. Our third's definitely going to matter. We're left with our half, which never cancelled anything. And we're left with our subtract 1 over 3n plus 2, which never cancelled anything. At this stage, you could stop here, but you may well get a question asking you to write it as a single fraction. So I'm going to go all the way through that and just make sure we get this in a nice form. So if you're asked for this as a single fraction, we're going to want a common denominator. So let's just make the common denominator make the common denominator 2 brackets 3n plus 2. So that's going to be 3n plus 2 over 2, 3n plus 2, and then subtract 2 over 2 brackets 3n plus 2. And we're even going to get a nice simplifying here. We've got 1/3 of, and then 3n over 2, 3n plus 2. And we're going to get some nice simplifying happening, bringing the third in now, because we've got 3 on the numerator and the third on this denominator here. Those are going to simplify, and we're just going to be left with n over 2 brackets 3n plus 2. There's not going to be a nicer form to write it in than that. Okay, so that's one case. So that's a case where we were given the result where we're splitting it into 2 terms. I want to just take it up a notch now and look when we've got 3 terms, because it can be more difficult to spot the simplifications that happen in these cases. So second example, the result I'm going to give you here. So I'm going to say we're given the 3 over r subtract 1, subtract 2 over r, subtract 1 over r plus 1 is equal to 4r plus 2 over r brackets r squared minus 1. And the result I'm going to ask you to look at here is the summation from r equals 2 to n. So slight complication, I'm putting r equals 2 in. There's a reason though. If I put r equals 1 in, that denominator would be undefined. So there's a reason I'm asking this question like this. I want to just do the summation of the thing on the right-hand side of the identity we've just been given. So you could be given this question without having been given the result, but you'll need to use partial fractions, which you may or may not have covered yet at the time of watching this video. So if we're given that, the first thing we're going to do straight away is say, well, let's rewrite what's in our summation to make use of what we've been given. So we can rewrite as 3 over r minus 1, subtract 2 over r, subtract 1 over r plus 1. Note, the fractions are exactly the same this time, so we don't need to worry about having something outside the summation. And same thing as before, let's start by subbing in. So we're going to sub in the first 3 terms now. Our first value of r in this case is r equals 2, because we're told that's the first one we're subbing in. So if we sub in r equals 2, we're going to get 3 over 2 subtract 1, so just 1. I'm going to place 3 over 1 just for now, just because sometimes it will make the simplification easier to spot. This is probably overkill in this case, but it's just a good habit to get into. So then 2 over 2, again, I'm not going to worry about simplifying yet, but we've got plenty of time to do that. Subtract 1 over 3, so that's just from subbing in r equals 2. And then we're going to add in what happens when we sub in r equals 3. So if we do that, we're going to end up with 3 over 2, subtract 2 over 3. Sorry, I'll try and keep my handwriting legible here. Subtract 1 over 4. And then if we sub in r equals 4, because like I say, I'm always going to sub in the first 3. And on the last one, we could have got away without subbing in the first 3. On this one, there's no way you can get away without subbing in the first 3. The next one here, we're going to go 3 over 3. And again, I'm not simplifying yet. And actually, in this case, it will make our life easy to see what simplifications are going to happen. Subtract 2 over 4 minus 1 over 5. Before I worry about spotting the simplifications, let's do the final 3, because that might, if we see it in the general form, it might make it easier for you as well. So subbing in r is n subtract 2. We're going to get 3 over n subtract 3 minus 2 over n minus 2, subtract 1 over n minus 1. And then subbing in r is n minus 1, we're going to get an n minus 2 there, an n minus 1 there, and then here, and finally, subbing in r equals n, always the easiest one to do because you're just literally replacing the r with the n. N minus 1, subtract 2 over n. subtract 1 over n plus 1. Okay, now we need to hopefully find a simplification. Otherwise, we've just written it out in longhand and it's not got any nicer at all. Whenever you have one splitting into 3 terms, you're going to have to find a simplification involving 3 terms. And if you've written the original thing with the denominators in increasing order, it's always going to be a long diagonal. So it's worth looking at long diagonals. And in this case, we should see we've got subtract a third, subtract 2/3, plus 3/3. That's the reason I left it in unsimplified form. Because if I'd written plus 1, maybe it would have been a bit harder to spot a simplification, but hopefully we can see those are disappearing. And then the next diagonal would disappear, but again, we're just not writing out every row because we can't write out every row. Let's look at the bottom ones. We go subtract 1 over n minus 1, subtract 2 over n minus 1, and then we're adding 3 lots. So those are going to simplify. And what we're going to be left with once we do all the simplifications, those 3 in the top left corner and those 3 in the bottom right corner. So we're going to end up with 3 over 1. Well, at this point, I'm happy to write it just as 3. Subtract 2 over 2. Well, let's just subtract 1. Plus 3 over 2. And then subtract 1 over n. Subtract 2 over n. Subtract 1 over n plus 1. Let's do what simplification we can. I'm not going to worry about getting it as a single fraction in this case. So 3 subtract 1 is 2. Add 3 over 2. Well, that's 4 over 2 plus 3 over 2. So that's 7 over 2, I hope. And then subtract 1 over n, subtract 2 over n. Subtract 3 over n, and subtract 1 over n plus 1. If you did want a single fraction, now make a common denominator, but that should be sufficient there. So that's an n. It looks a bit like an r. So just to summarize what we're doing there on both of these questions. So we're writing it out using the results we've been given. The one thing to watch out for is if those denominators are different, you're going to need a factor on the outside. Write out the first 3 and last 3. Make sure you clearly pair what's simplifying. You will be docked marks if you don't make it clear what you're simplifying. Then you can go through and you're away. And same thing, but with the 3 terms, you're going to have to look at 3 terms that simplify. But as long as you've got the results in a sensible order with these increasing, it's nearly always going to be along the nice diagonal. So start by looking at the diagonal before you worry about trying to find anywhere else. Okay, hopefully that was useful. Thank you very much.